project debater is one of the projects that everybody is jealous that they are not participating in, because it's a very lucrative and very advanced AI project. I will also say that it was I told Roy before the conference, I worked in IBM Research, and I was part of the team there, of the speech team. And in the picture he sent of his team that he's going to show you, I saw several friends of mine. For me, as being an IBMer for many years, it's a really pleasure and honor to invite you today to speak. Thank you.
Thank you very much, Nava, and good afternoon. So I'm going to talk about Project Debater, the first AI system that can debate with humans. I'm going to tell you how the system was developed, how we evaluated it, and finally how debating technologies can be applied to solve real-world business problems. So perhaps the first question is, why developing and debating AI? So debating and argumentation are important capabilities of human intelligence, and we use it every day to convince each other or to reach decisions. So from research perspective, it is a very interesting goal for AI research. And we at IBM Research have a long history of AI grand challenges. In 1997, Deep Blue was the first computer to beat chess world champion Garry Kasparov. Later in 2011, Watson was the first computer to win the all-time champions in Jeopardy. And shortly after that, Dr. Noam Slonim from the IBM Haifa lab in Israel proposed the idea of developing AI that can debate humans. And after a long review process, this was chosen as the next AI Grand Challenge for IBM, and this became known as Project Debater. So development started back in 2012, and this large and talented team of researchers and engineers developed Project Debater for over 6 years. The development was done mostly in Israel with collaboration with several other labs in India, China, Ireland, and the US. Finally, in 2019, we demonstrated a Project Debater in a live event. It was part of the IBM Think conference in San Francisco. And Project Debater was engaged in the debate with Mr. Harish Natarajan, one of the top debaters in the world. And a few words about the format of this debate. So first of all, there is a topic to this debate. It is called the motion. In this debate, it was, we should subsidize preschools. Project Debater was supporting the motion, and Harish was opposing the motion. Each side had 4 minutes opening speech, then 4 minutes rebuttal speech in which one could answer the arguments of the other side, and finally 2 minutes of summary speech, taking together about 20 minutes discussion between AI and a human. The topic was not, Project Debater was not trained on this topic. It was a new topic for both Project Debater and for Harish. And no automatic, no human intervention in the course of the debate. It was fully automatic. So let's watch a short clip from this event.
Greetings, Harish. I have heard you hold the world record in debate competition wins against humans, but I suspect you've never debated a machine. Welcome to the future. When we subsidize preschools and the like, we are making good use of government money because they carry benefits for society as a whole. For decades, research has demonstrated that high-quality preschool is one of the best investments of public dollars, resulting in children who fare better on tests and have more successful lives than those without the same access. Secondly, a few words about poverty. While I cannot experience poverty directly and have no complaints concerning my own standards of living, I still have the following to share. Regarding poverty, research clearly shows that a good preschool can help kids overcome the disadvantages often associated with poverty. The OECD has recommended that governments subsidize pre-primary education to boost performance in poorer areas.
Well, thank you very much, everybody. It's a pleasure to be here for this historic event. And it certainly was a pleasure to listen to Project Debater. There was a lot of information in that speech, and lots of facts and lots of figures. The problem, though, is the reality of subsidizing preschools is one which does not deal with the underlying problems in society. If you massively increase the number of people going to preschool, they're all going to be the ones going to the high-quality preschools. In a competitive environment at the age of 3 or 4, when you're learning that that other child is potentially better than you, when you realize you aren't necessarily as talented as someone else, that huge psychological damage for many children may mean that preschool is actively harmful.
Among other things, I think Mr. Natarajan suggested that preschools should not be subsidized because this will reduce their quality. I would like to offer a different view. I disagree with my opponent. Subsidizing preschools will have no negative effect on their quality. If anything, the opposite is true. One of many reasons is that subsidizing attracts more skilled and qualified people to the field, improving the quality of preschools for all. My opponent claimed that preschools are harmful. I believe my argument suggested that the benefits outweigh the potential disadvantages. I touched upon 3 issues: children, students, and crime. Specifically, I noted that preschool education improves children's development. In addition, I suggested that attending preschool helps students succeed. And a final point to consider is that preschool can prevent future crime. We should subsidize preschools. Thanks for your attention.
Okay, so a natural question at this point would be, how does it work? So this is how it works. Quite complex, as you can see, but I will walk you through it. So first, the input and the output. So the input is just the debate topic or the motion. In this case, it was subsidized preschools. And the output are the 3 speeches, the opening speech, the second speech, and the final speech, delivered through expressive text-to-speech that we developed that aims to emphasize the important parts, put some emotion, and so on. Now, the building blocks for building a speech are the arguments and where the arguments come from. So one important source is extracting the arguments from a large corpus, which is called argument mining. So we had a corpus of 400 million articles, which we licensed from LexisNexis. It comes from thousands of news sources. And we add some semantic annotations to it, wikifycation, named entities, and we indexed this corpus at the sentence level. So it includes 10 billion sentences. Just indexing such a large corpus is a challenging task by itself. And this is done offline, before the debate starts. When we get the debate topic, we retrieve relevant sentences, and the sentences go through a sequence of classifiers that perform claim detection, evidence detection. We look for evidence like research results or expert opinions. And then stance classification, which is very important. Suppose that you have a very good argument, very relevant to the topic, but it supports your opponent side. It would be very embarrassing to use this argument in your speech. So stance classification should also be very accurate. Then we need to organize these arguments into a coherent speech. So there are additional actions that we should take care of, removing redundancies, clustering the arguments so we have a coherent paragraph, each paragraph about a coherent topic, and theme extraction. You remember that project debater said I touched upon students, crime, and children. So these are the themes. And in addition to argument mining, we had another source of argument, which is something that we learned from the expert human debaters that we worked with. So they don't have access to a 10 billion sentence corpus. They have in their head a repository of arguments that they can reuse in similar circumstances. For example, many debates are about banning something, like we should ban the use of alcohol, we should ban smoking, and then a common argument against it would be that banning something would create a black market, which has its disadvantages. However, we cannot always use these arguments. For example, if the motion is we should ban flag burning, banning it will not create a black market for flag burning. This is more challenging. And by the way, so we developed this knowledge base of principled arguments, and the system needs to identify when it is appropriate to use them. By the way, this knowledge base also includes jokes, as we heard in the clip, and quotes, all to make the speech more interesting, because just shooting facts for 4 minutes may not work. We need to keep the audience engaged. Then additional operation for the speech construction, we need to context selection, make sure it will fit into 4 minutes, do some rephrasing to make the text fluent, and as I said, deliver the speech using the expressive text-to-speech. So all this was just the opening speech. Now we get to the difficult part, which is the rebuttal. Namely, we need to listen to 4 minutes of speech made by the human opponent, understand these complex arguments that he made, or she, and come up with rebuttal. And the basic idea here is that we are trying to anticipate the arguments that the opponent would make, check if they were indeed mentioned in the speech, and then come up with either counter evidence from the argument mining corpus or counter arguments from the argument knowledge base. So the arguments come from both of these sources, the arguments and the counter arguments. So basically, this is how it works. And as you can imagine, there are many interesting research problems hiding within all these components, and indeed we published more than 50 papers about these various components and released many datasets, and they can all be found in our website. So next, I want to spend a few minutes talking about this article, An Autonomous Debating System, an article that we published in the Nature magazine last year, which is a nice summary of this significant research effort, which took many years. And we had several contributions here. First, it's the first time we describe Project Debater in its entirety. And along with this publication, we released many of the capabilities of Project Debater as web APIs. We call it Project Debater Early Access Program. And it includes diverse capabilities that we developed over the years, including basic NLP tasks like clustering, semantic relatedness, fast wikification, various argument mining APIs for claim detection, claim boundaries detection, evidence detection, and stance classification. And finally, more high-level summarization services, including the narrative generation, which is similar to the speech generation, and the quantitative summarization, which we call key point analysis, which I'll talk more about later. And finally, we also discussed the differences between Project Debater and previous AI grant challenges, which were mostly focused on board games like chess and Go. So one of the things that make Project Debater a really challenging grant challenge is the evaluation. Because if you are developing an AI to play chess, then when the game is over, it is clear who won and who lost. And this has various implications. For example, the AI can play against itself, and so on. However, evaluating a debate is much more subjective, and there is the human side, and so on. So in the live event, we could let the audience vote before and after the debate whether they support which side of the debate they support, and we could say that the winner was the side that pulled more people to their side. However, this cannot be repeated if we want a robust evaluation over many topics. We cannot repeat it for many topics. And there is also inherent bias in this method, because if initially 80% of the people support your side, then your chances to pull more people is much lower. And still, we wanted to perform robust evaluation of Project Debater, beyond this a few live events, but on a broad range of topics. We also wanted to compare it to other AI technologies, but the challenge was that no other AI system could engage in a full debate. So first we focused on the task of just creating the opening speech. So we compared Project Debater to several baselines. Some of them create arguments, and then we concatenated the arguments into a speech, and some of them create a full summary or a full speech. So we compared Project Debater to Summit, which is a multi-document summarization system, to version of fine-tuned GPT-2. One was fine-tuned on complete speeches, one was fine-tuned on arguments. Then two baseline that involved human intervention. One was based on arguments composed by humans. One was a configuration where the arguments were found by Project Debater but curated by humans. And finally, the upper bound, was the human speech created by a human debating expert. So as you can see, Project Debater the speeches were evaluated by a large set of human annotators, of crowd annotators, and which had to rank it between the quality of the speech between 1 and 5. And as you can see, Project Debater performed much better than the other baselines and quite close to the human upper bound. In addition, we also wanted to evaluate the full system, namely including the rebuttal phase. So for this purpose, we gave the annotators 3 speeches: the debater opening speech, the opening speech by the human expert debater, and automatically generated a rebuttal speech by Project Debater, and asked the annotators to evaluate the first and the third speeches, which were created by Project Debater. And again, we see high performance, on average over 4 out of 5 in the assessment of the speeches. Okay, so the live event got a lot of media attention, a lot of positive feedback, and of course, a very exciting moment for the team who developed the Project Debater for many years. Now the question is, what's next? So, After this big live event, Project Debater transformed from developing an AI system that compete with human debaters to developing debating technologies that can help humans make better decisions. So as I mentioned, we released many of the capabilities of Project Debater, which we developed over many years, as web APIs. They are free for academic use and can also be licensed commercially. And we worked with clients on applying these technologies to real-world problems through the early access program. Some of the technologies that we developed, like advanced sentiment analysis and clustering, were already integrated to IBM Watson products. And we continue research in NLP, NLU, NLG, and computational argumentation to further advance this field. Finally, I want to tell you about a technology that we developed over the last 2 years in Project Debater, which we call key point analysis. So if you think about it, the debater speeches summarize many arguments mined from a corpus. But another important use case is to summarize a large collection of opinions. And this can be textual survey responses, user reviews, customer feedback, social media, and so on. So this situation arises in many different use cases. And key point analysis is a novel summarization technology. It summarizes this collection of opinions as a short list of concise sentences that we call key points. And it maps the input sentences to these key points. So the salience of each key point can be represented by the number of matching sentences. And I will show an example. So this screenshot is from the Project Debater early access program. You can Google it, and you can log into the website as guest and confirm the terms. And then you get to this screen, and we have a demo for key point analysis, where you can upload your collection of comments and run key point analysis and get the results. So, for example, here we have a collection of survey responses from the city of Austin, Texas. The citizens of Austin were asked if there was one thing that you could tell the mayor of Austin, what would it be? And here in this file you have 1,000 comments, and the question is how we make sense of this large collection of comments. So we can feed it, we can just upload the file, and this is the results that we get. These are the results of key point analysis. So as you can see, in Austin, the main points were traffic congestion needs major improvement, the city is becoming extremely unaffordable, Austin needs better public transportation, real estate taxes are too high, the homeless population needs more help. And for each such key point, they are ranked by the number of matching sentences. And as you can see, this is a summary that it is concise, it is quantitative, and it is actionable. It is like a to-do list for the mayor of Austin, a prioritized to-do list. And we can click on each of the points and see the matching sentences. Let's take the second one. So you can see here the sentences matching to the key point. The city is becoming extremely unaffordable. So you can see the city is, it is too difficult to afford to live here. The city is too expensive, and so on. So you can see that we are able to identify different paraphrases of the same idea. Okay, if you want to learn more about Project Debater, the whole live event is available to watch on YouTube. You can read our Nature publication, and even watch a documentary about Project Debater straight from the Copenhagen Documentary Festival.
Can you say something why in Israel or why with the team in Haifa and of all places? I mean, why that team?
So, because here it was suggested, because Noam suggested it, and then it was selected as a grand challenge. So the development was done here. You can, I mean, maybe we as Israelis, like to debate and argue. I think it's a good fit, but I think that over the year we grew a large team of experts in debating technologies, and in parallel to this grand challenge of us working on Project Debater, also this area of computational argumentation developed in academia. The first workshop on computational argumentation was in 2014, the same year that we had our first publication on Project Debater. So it is now a significant academic research topic as well.
Okay, so the people we have, by the way, we have joining us via the online platform Event Place. They are taking care of that's the company. We have 150 people online, just for you to know that we are not alone. So this is very good. And now I will give you to ask it properly.
Thank you. If the human debater makes a solid argument, is there a chance for the AI to change its mind?
Well, I think you are giving too much credit to the AI. But I think perhaps, I mean, here for this live demo, debater took one side and the human took the other side, but perhaps if you look at the real use of the debater capabilities is to that it can show the human both sides of the arguments, the pros and the cons, and then one can reach better decisions.
Anyone else? Yes.
Can I ask more than one? Okay. First one, you showed the pipeline, which has a lot of individual stages, where each one of them actually very challenging. So I also noticed very impressive responsive time on the video. So my question is, which part of the pipeline actually works in real time?
So as I said, first of all, for example, for the argument mining, as I said, all the indexing and semantic preprocessing was done offline. And then there has been, I think, it's not just a research project. It's a research plus engineering, and it was a whole engineering team working alongside with the researchers to make it fast, also to make it resilient. Everything should be backed up, and so on. So it was also a significant engineering effort.
Okay, thank you. And can I ask another one? Actually, when we people argue, most of the time we are subjective because we are driven by our emotions. So I think that this is the biggest advantage of this machine, that it is actually objective. But you mentioned that you're trying to bring emotion analysis to its generation process. Why?
So, so it is, known since the ancient Greeks who talked about rhetorics that, the appealing to the emotion is important, is one important aspect of rhetorics. And definitely this is, the strength of the debater is the ability to pull a lot of facts, but, okay. And, but the humans is much better on, addressing the emotion. And so we have an expressive text-to-speech component, but it is, the abilities there are far than what a human can do.
I do agree that when the text-to-speech will be as passionate like the speaker was with his South African accent, it was really more pathos into the argument. But I guess we still have work to do, but this is very impressive. And thank you very much. It's our honor. Thank you very much.